And so here we want to find the polar equation for this type of ellipse. And we want to show that the corresponding equation is r squared equal to b squared dividing by 1 minus e squared times sine squared theta. So we want to show that the polar equation for this ellipse is this. And recall that for this ellipse right here, the center is at 0, 0, and so the focus is right here, and then we have another focus right here, and then the distance from here to here is A, and the distance from here to here is B, with the center at 0, 0. And so we want to find the corresponding polar equation for this ellipse. And so we have an ellipse that's elongated vertically. And so here we have the rectangular form of the ellipse. And so we use these two formulas right here. X is equal to r cosine theta, and y is equal to r sine of theta. These are the formulas that relate the rectangular system and the polar system. So in the place of x, we have r cosine of theta. In the place of y, we have r sine of theta. And then dividing by b squared here, and dividing by a squared here. And then to simplify, we have r squared times cosine squared theta, and then here we have r squared times sine squared theta. The common factor here is r squared, so let's pull it out. So we end up with r squared times cosine squared dividing by b squared plus sine squared dividing by a squared. Now let's combine these two fractions. So we'll cross multiply. So we have a squared times cosine squared plus b squared times sine squared dividing by the product of a squared and b squared. So that's how we combine these two fractions. Now let's multiply the left side, the right side, by the reciprocal of this. So to form the reciprocal of this expression, we just turn it upside down. So the reciprocal of this expression is a squared times b squared dividing by a squared cosine squared plus b squared sine squared. So just turn it upside down. So multiply the left side, multiply the right side by the reciprocal. And so this expression multiplied by its reciprocal, we get 1. So this times this is 1. 1 times r squared, which is r squared. And then the right side, we have a squared times b squared dividing by a squared cosine squared theta, and then plus b squared sine squared theta. So this is the polar equation right here, and then we'll go ahead and simplify it a little bit more. Now let's divide the numerator and the denominator by a squared. So divide the numerator by a squared, we get b squared. And then divide each term in the denominator by a squared. So we have a squared cosine squared theta divided by a squared, which is cosine squared theta. And then dividing by a squared here, we get ab squared dividing by a squared. And one more time, for this type of ellipse, the relationship between a, b, and c is a squared equal to b squared plus c squared. And so we have b squared is equal to a squared minus c squared. And then also recall that the eccentricity is defined, E is defined as c divided by a, or E squared is c squared divided by a squared. So in the place of b squared, we have a squared minus c squared. A squared dividing by a squared is 1. And then minus c squared dividing by a squared times sine squared. 1 times sine squared is just sine squared. And then minus c squared over a squared times sine squared is minus c squared over a squared times sine squared. C squared over a squared is e squared. And so we end up with r squared equal to b squared divided by 1. A cosine squared plus sine squared is 1. Minus e squared times sine squared theta. And therefore for the polar equation for this ellipse, which is this type of ellipse, is r squared equal to b squared divided by 1 minus e squared times sine squared theta.